and welcome back to Research Methodologies. In this week, we'll be talking about research design. And for this session, we'll start off with an introduction on what the design on very broad lines should look like. So this is the research design that will help you to start working on your thesis. So, what are we doing this week? Basically, this week I'm hoping to give you some answers on questions like how do I design my research? How do I formulate research objectives and research questions? What type of research are there? How do I select appropriate methods? And is the research method I pick feasible and ethical? So, in this session, we'll first have a quick look at the MSc thesis as it stands. So, an MSc thesis, what's so academic about it? Why is it different than, say, a thesis at a polytechnic or a science project at your school? Well, basically, generally speaking, for instance, if you've done your internship, you go on your internship and the company or the institute that you worked for had a problem. They would like you to solve it and give you an answer. And give them an answer. That's all they want. They really don't care why there was a problem most of the time. They also don't care why your solution works. They just want your solution to work, problem fixed, and that the actual money flow keeps going. So, what's the difference with an MSc thesis? And this is especially important if you go to a company. Well, if you do your MSc thesis, you have to do a little bit more than just fix the problem. In fact, you have to prove to us, from the academic side of the supervision, that you understand the problem, that you've analyzed it, that you can put it in some sort of academic framework. What is it caused by? What theory lies behind that? Then develop some sort of model that works towards a solution. And the model basically gets applied to the problem and that will solve the problem. But the development of the model is far more important in an MSc thesis than the actual problem solving. In fact, not being able to solve the problem might also still lead to a valid master's thesis. So that makes a vast difference between a master's thesis and, for instance, an internship project. It's also something that, especially if you work with a company, they find hard to understand because they see you to a certain extent as a reasonably cheap, if not free, problem solver. So, for a master's thesis, what do you add to the body of science by making a model to which you then find an applied problem, because this is a technical university, to validate that what your model actually solves what you're looking for. And far more importantly, you have two deliverables. So whereas for a general internship you have an answer to a problem, with an academic thesis you may have an answer to a problem, but far more importantly you should also have an improved and validated model and recommendations. It might, for instance, be that based on your model you can tell them that the problem is much bigger than they've ever anticipated, or that based on your model they don't actually have a problem, or that the problem is somewhere else. So in that sense, it's a whole different ballgame. For many companies, this is sometimes a difficult thing to understand. So it's therefore very important that when you do your thesis at a company, that you have this discussion with the company and have them understand that the academic standards that we require are much, much higher. Vice versa, if you've had a real good internship where you were known as the problem fixer, your thesis might be a bit of a disappointment for you if you're going to have to dig first deep into analysis and the modeling. But that is what is important to us. That is what makes you a master of aerospace and a master of the academic training that we've given you over the past few years. So for us, it is really important that you prove to us that you can independently frame your work in academic literature, find suitable theories, suitable methods of analysis, adapt, modify, and create possibly some of your own in order to create a workable model that will not only solve the problem that you were given to solve, but also actually adds a little bit to the body of science and the body of knowledge of what's out there. And basically you do a little bit more than just be a problem fixer. So please keep that in mind, especially if you have your own thesis ideas and you bring that to your supervisor, that is what they are looking for. So, how do you design your research? Well, let's look at a very high order level and let's look at the strategic framework for research. The strategic framework for research, and comes from the book that we use with this course, so from Verschuren and Durewaard, they argue that research design basically consists out of two different phases. You have a conceptual design and a technical design. Now, as engineers, we really like the technical design because that's when we get going, we find our materials, we make a plan, and we go for it. However, the conceptual design is what needs to be done first. This is sort of like the preparation work. And sometimes it's a bit drawn out, but if you do it right, the technical design will go faster, and even more importantly, your whole thesis process will go faster, your whole research will go faster, because you've got very well cordoned off what it is and what you are and are not going to research, what does belong to your problem, what doesn't belong to your problem, what you mean by what definition, and how you've operationalized them, and all those things. So let's focus in first on conceptual design, and we'll get to technical design in a little bit. So if we look at conceptual research design, basically it is the modeling of the content of the research. It basically determines what, why, and how much is going to be studied. So rather than looking at everything, you're going to put boundaries in. You're going to decide why you're doing this and not that, and be able to explain that to people, because people will forever during the 6-7 months that you're doing your research go, why didn't you do that? That's because in the conceptual research design phase, we agreed, and that's what I mean, you and your supervisor agreed that this is what I'm going to study. So also why you're going to study that, and why you're not going to study something else. And also how much of it is going to be studied. Please realize that science is never finished. No one graduates or no one finishes any research project of any kind with no questions left to answer. That is what makes what we do so much fun. That's why we do what we do and why we enjoy it. But it can also be a killer, because if you think that, oh, I know exactly when I'm finished because then I've studied everything, that is not the case. So that's why the conceptual research design is very important, because that's where you sort of make a contract with yourself. What am I going to do? What am I not going to do? And what is for studies that follow after me? Typically in the conceptual research design there are 4 phases. You have the objective of the research. What is it that we're going to do? Then the framework within which that operates. Then you start looking at the research questions. What answers am I looking for? What's my conceptual model to a certain extent? And then, very important, you put together some definitions and operationalization. And I'll come back to that all in one of the next videos. But for now, this is what is part of the conceptual research design. The next phase is then the technical research designs. And that's the activities you need. That's just where the doing gets planned. So there you list the activities needed to realize the objectives set out in the previous phase, the conceptual design phase. So it's very hard to concisely and well plan the activities if you haven't got your objectives clear. For instance, let's say, I want to investigate the human factor errors in maintenance. Great thing to investigate, but how can you determine the research activities if you haven't actually defined what the objective is and who you're going to study? Those are things that you really should have done in the conceptual design phase, because otherwise it's good, I could do this and I could do that, and before you know it, you've got 15 activities, half of which in 2 months' time seem completely inappropriate because you didn't make your choices in the conceptual design phase. So basically, technical research designs is the how, where, and when. How am I going to do it? Where am I going to do it? And when? And every time you reflect back on your conceptual design phase to ensure that your how, where, and when fits into your conceptual design. Which also means that there are some research activities that you may really enjoy, may not happen. That is the first part of what is sometimes lovingly called killing off your darlings. It's a bit of a shaky expression, but it means that some of the things that you really care about in your research may not contribute to the answers of your thesis. So therefore, as much as you like doing them, they are not part of the research that you need to do. Now, the technical research design can also be defined in 3 phases: the strategy, the material, and the planning. So this is also something that we'll come back to. So you have these two phases, and the next thing that you now need to do is focus in and zoom in on those further phases. And that is what we'll do in the next video.